Everybody is doing good with the new normal of working from home. Okay, so today's topic is Istio Service Mesh. So basically, this is a primer talk focusing on the W's of what is Istio, how to use it, why to use it, and where to use it. And I am Prashant KSR, and we are the people who are in between you and your lunch for today. So I've been working at Dell for quite some time. It's been my eighth year now, and I'm a Linux evangelist, and I've been associated with the OSA days for 3 consecutive years now as a speaker. Before that, I used to attend every year as an attendee as well. And this is my LinkedIn and Twitter in case if you want to connect me offline, if you have any ideas or questions, if you want to discuss further any of these activities. Yeah, Vinita.
Hi everyone, a very good afternoon to all of you. So I have been working with Dell for the past 5 years. Last year we had conducted a Linux workshop for OSI days. Other than that, I'm very passionate about data mining and search engines. And besides all this, I am a core member of Women in Technology. Also, if you have any queries concerning this talk or anything related to data mining and search engines, you can connect me in LinkedIn and Twitter. We have shared the handles. And welcome to our session on Istio.
Okay, so this is going to be the pretty much the agenda for the next 30 to 40 minutes. So we'll be going through an orientation, trying to understand how this microservices has evolved, and also we'll look at what exactly is service mesh, what are the requirements associated with that, and also we'll try to look at Istio, which is a service mesh. We try to understand the W's of Istio service mesh, what is Istio, why Istio, where to use Istio, and how to do it. In order to understand the how part, it's really important to understand the Istio's architecture and also trying to understand Istio components. Then we'll also look at the Istio core features. The three core features associated with it are the traffic management, observability, and security. And then we'll wrap up and look at some of the questions and stuff like that. I know it's really hard to cover most of these stuff in 30 to 45 minutes, but what we can assure you as part of this talk, right? You should be able to understand the overall gist of why Istio should be used, and it should actually help you kick off, start using it. That's the whole goal for this talk for us. So without waiting further, let's start with the orientation. If we really look at the last past decade, the way data centers have been designed and deployed has drastically changed. So if you really look the way the virtualization, containerization, and the cloud technologies have evolved and changed the entire course of data center management. So if we really look at if we go back a decade before, we used to have an idea or a thought in our mind, which we put it into a program kind of thing, and start developing a UI and a data access layer and write a business logic around it. So once you publish the project, then you start getting requirements, enhancements, either through your marketing or customers or through issues. So what eventually happens in course of time is you start introducing a lot of features in your business logic, and it just keeps growing and growing. So there's no stop to that. So what exactly happens after a couple of releases or more, when you start introducing more features to it, it becomes a huge gigantic monolithic picture. So, and with that restriction, what you try to do is you try to go and install on a one particular hardware to get the service up and running. But that's not going to work with when it comes to scalability and meeting the. So now if we really look at the data centers design, right, it is mostly customer driven, data driven, and it is mostly the requirement. You have to meet the requirements. So in order to pursue that, people started looking at a different way of modularizing this entire business logic into different parts. Though they call it as a microservice, right? It is actually a service which will do a one particular task of your entire business logic, and all of these microservices together constitute your product and will work on it. Yeah, that is well and good. You started doing microservices, it started to give you results, but what exactly are the challenges, right? What all the challenges you can face through it? As soon as you start distributing the microservices, your logs get distributed. So you should start. One of the biggest challenges is to have this log aggregation. And also, if there are many requests happening across microservices, you will have a distributed traces of service requests happening. So is there a way we can actually trace this request? We are not sure. And when it comes to authorization and authentication, to be very honest with you guys, whatever model you follow, whether it's monolithic, microservice, or whatever model you try to distribute your software, security is your biggest enabler or disabler. It actually plays a very key role in the data center design nowadays. So if you have to have different services, you know, trying to transact with each other, then you need to always think about the security associated with all of this. You can just say, okay, just using TLS will solve the problem, right? That actually does not solve the problems. There are many more things which we'll be discussing in our future slides. Then also there will be an asynchronous events which will be associated with these microservices. How do you handle them? And also when it comes to auditing, how do you hand audit to a fine granular level across these microservices? That is, these are all key challenges which you will be facing. And one of the key features which you have to have when you say microservices is you need to have a program in place or a product in place which actually discovers the service. Whenever there is a new service spawned as a microservice or something, it has to be discovered. So eventually people have moved from monolithic to micro, and as usual with any change, right, you'll start facing challenges, limitations associated. So change is the only constant, but we start facing challenges and limitations, right? With to address these challenges, right, people have started evolving a lot of libraries around it. To initially start with, right, Netflix was the first one who has actually open sourced microservice patterns and libraries in right around in 2011. Then started coming the Docker, which has introduced the containerization to the word. So when I start talking about Docker, right, I just wanted to give a word of caution here, because most of the people actually consider Docker is containers. No, that's not really true. Actually, containers have been there for quite some time, right from 1980s. If you really look at OpenBSD, there was something called jails, and if you look at the traditional Linux, it also had something called chroot. Then why did actually Docker became very famous? In a layman term, if I have to really say it right, chroot is our Shrek and Docker is the Hulk. See, they both look similar, they both look green, but when it comes to capabilities, they are very different. Even I'm not sure how many of you are aware, at this point of time, Google also had a similar engine called Let Me Container It For You. You can just Google it, you will be able to find. So what change did Docker exactly bring into the infrastructure? It actually made the user space tools very handy and easy to use. That's the reason it became very famous. Then when it comes to contain, so with Docker, containerization has taken a big blow and people started using it all around wherever they are able to solve their problems. That's where Google came up with a workload orchestration around this containerization, which is called Kubernetes. Kubernetes is a great tool, definitely, but it has its own limitations when it comes to interconnection of pods. It does not have tracing of individual requests. It actually gives an overall health of the pod or the cluster, but it does not give a granular level things there. Also, there was something called Spring Cloud, which is an enterprise microservice framework associated around Java. But though many of these things came, the only thing which took my interest was around the service mesh, which is Istio. Istio is one such framework which supports service mesh. Okay, so let's right jump into what is a service mesh. Why am I so impressed with it? Basically, it is nothing but an infrastructure layer which makes service to service communication. What is a factor which it is bringing? Along with bringing this service to service communication, it makes it fast, safe, and reliable. It is not something a black box or something which you cannot look into. It is a very transparent layer which runs on top of your services, and it also ensures that all the communications, all the network around your microservices are generally available, and they are aware of these protocols like HTTP and remote procedure calls. gRPC stands for global remote procedure calls. And also this will be used as an observability tool to observe what all things are happening around the services in your mesh. And it also can be used as a security tool. So if I really talk about a service mesh, these are the things which are trying to use to solve the problems which we discussed a couple of minutes back associated with microservice. So if we really look at, when I'm saying service mesh, it solves the problems. It is going to resolve the issues whichever or the limitations which we just spoke. What are exactly are the requirements of a service mesh, right? These are all the things which are associated with the requirements of a service mesh. To take an example, it should be able to discover a service whichever has been spawned in your mesh. It should be able to rate limit. What I exactly mean by rate limit here is it should be able to control the percentage of traffic going to the services running on your mesh. Also, it should be able to manage all of this seamlessly. It also should provide you end-to-end authentication using the tokening part, which we'll explain further. Also, it should support something called canary releases. Canary releases is an important thing to understand. Let's say if you're trying to bring in a new feature, do you want to really drop in that to the entire world until you face issues? Not really. What service mesh provides you a feasibility to introduce this particular feature only to a few set of services and lets you test these scenarios. Once you feel okay, this is not facing any issues, you can actually push those to across all the services. That's what I really mean by canary releases. Also, another key feature which has to be supported by a service mesh is it should be able to provide you granular level metrics what is happening across your microservices. Also, you should be able to clearly articulate and monitor at what stage, at what point of time, which request is at which place. So it allows you a granular level monitoring as well. So now that we understood what is a service mesh, what are the requirements associated with it, let's directly jump into Istio. What exactly is Istio? Istio is nothing but it's a service mesh, whatever we have discussed till now, which is designed to connect, manage, and secure your microservices. If you really look at the four pillars, what are associated with it are it is allowed to connect, manage, control, and observe. So it is an open source project which was created by in collaboration with Google, IBM, and Lyft in 2017. And one of the key features, if I really have to talk about, is if you want to adapt this service mesh, it expects you to have zero code changes from your services perspective. That is really important. So if you want to adapt any framework, it should not really tie down to your service level. It should be independent of it, and by you without making any changes, you should be able to adapt it. So this is what exactly is Istio. Then let's try to look at the various W's of Istio. Like now that we have seen what is Istio, let's try to see why use Istio, right? These are the key features which are supported by Istio, which will be used to solve the challenges and limitations what we discussed on microservices. Um, which is load balancing, traffic behavior, access controls, metrics, log, tracing, and it also allows you to give security on service to service communication. What I really mean by metrics, log, traces, access control, traffic behavior, load balancing, all of these will be covered as the core features of Istio, which you'll be seeing in another 10 to 15 minutes. I hope until this point of time, you guys are able to connect what is Istio, why is Istio. Okay. Then we look who is Istio for. So if you look at various phases of your life cycle or DevOps, right, it can include infrastructure operators, platform engineers, app developers, security admins, quality assurance. Each of them can play a role in Istio. That's another key feature which we really like. Like example, app developers can really use this to investigate what is a service mistake and behavior so that they can debug during outages. Security admins can enforce authentication and authorization policies right from there. Platform engineers can use Istio to build CI/CD tools for app developers, and it also helps you migrating your legacy services. Quality assurance is these are the people who mirror your production traffic to a test environment to see if any of the new features are breaking of the existing features. So that is one critical thing which. So I hope you guys are clear till now. So let's jump right into architecture. Over to you, Binita.
Hey, thank you, Quesar, and thank you for explaining, what is microservices and what is service mesh and what is Istio. So I hope by now everybody will be clear of what is Istio. Istio is just an open platform independent service mesh that basically provides you traffic management, policy enforcement, as well as telemetry collection. And it runs on different platforms like Console, Nomad, and Kubernetes. Now, having talked so much about service mesh and all, let's see how does Istio do it. So, if you want to see how Istio does it, it's because you have to understand what is Istio architecture, also what are the various components that are there in this Istio. So, on a high level, what exactly it is, if you look at the figure in front of you, you can see that there is a data plane. Data plane is nothing but a set of intelligent proxies that is, there across your services, and it is running along with your services. And then you have a control plane, and in control plane, you see that there are components like Pilot, Citadel, Galley, and also Istio. So let me tell you, this is latest Istio architecture. Before this, there were other components like Mixer and all, which has been deprecated. So this is with respect to 1.5 and above. Uh, and then you can see that the data plane along with the control plane with your services will form your Istio mesh, and there is an ingress and egress traffic which helps you for inbound and external communication. Now let's see in detail what exactly does this data plane and control plane do. So, like I said, data plane is just composed of a set of intelligent proxies named Envoy, which is deployed as a sidecar. Now, you will hear people telling about, instead of Envoy, they'll be using sidecar, they'll be using proxy, they'll be using all permutation combination of all this. But essentially, all of them means a proxy. And Envoy was actually made by Lyft, and it's built in basic C++, and it has a lower memory footprint. Also, when I tell about all your inbound and outbound communication has to go via this proxy. Also, this is not just what exactly Envoy do. So if you see at the diagram below, you can see that I have two services running, service A and service B, and inside every pod I have a container as well as a sidecar. So this is one thing you have to understand, that with along with your services, you have this Envoy proxy attached to it, and it is Envoy proxy that is responsible for a lot of things like load balancing. Majority of whatever you'd cover in traffic management is done by Envoy proxies. And Envoy is actually a open source uh, project, and it's used by multiple people like IBM, Lyft, and Google. So if you see that there are two services, service A and service B. So in order for service A to communicate with service B, the connection has to go via their corresponding proxies. So there is no direct to direct communication between service A and service B. Service A has to go, the request has to go through the envoy of service A to the envoy of service B, which will send the request to service B. And when this communication between these two proxies happen, all your authentication and certification is being taken care in this proxy level. Also, when I said that this is an open source, and Istio has taken it, and most of the Istio components which you see are being taken from a third party. But the only good thing is Istio has cleverly, build it up so that you don't have to deep dive into what these third party components and how to, how to actually integrate it with your services. So one question which everybody has is like, why do you need an Envoy proxy if it is open source? Why do you need an Istio? Actually, you don't need Istio. You can directly use Envoy proxy. But the only issue is it's a very low level tool and it can't be directly consumed for engineering purpose. So Istio actually hides all these complications it has, and helps you to do it in like ready to go method. Like I said, Envoy proxy is like not just a proxy. It's not just for sending the communication from one service to other service. Before this Envoy proxy came into picture, if you see, right, you see that you have service A, service B, and service C. And you know, this is your container. Basically, you have a container, then you have a JVM, then you have a discovery, load balancer, resiliency, metrics, tracing. All these had to be implemented by a developer, and this has to be replicated in all your services. Now, when you are doing something like this, right, not all services are same. There will be different. If you write one discovery method for service A, it might not work with the other one. So there is an issue of consistency. There might be some issues with security, consistency, connecting, requesting, all these things. But Envoy proxy actually hides all this from you. So it makes the life of a developer so good. So that is another key takeaway of what does a proxy do or a sidecar method do. So essentially, data plane is just the collection of all these intelligent proxies. And coming to the control plane is like the server side components of an Istio. Whatever you read in Istio other than proxies will fall under your control plane. And when I say about control plane, you see that there are components like Pilot, Citadel, and Galley. So let's start digging like what exactly does this do. Galley is like a configuration manager. So you are writing your own Kubernetes YAML file, but how will you make it converted to Istio configuration? So all these things are being done by Galley. Now we know that what is Galley? Galley is a configuration manager. And whatever configuration that Galley has given with respect to Istio, that is being pushed to your proxy via Pilot. So Pilot is like a driver for Istio, driver of Istio. And what it basically does is like it actually helps it service discovery as well as your proxy configuration is done via your Pilot. Uh, Also, it is like one of the main thing, that does lot of things, all the communication between your proxy and your data plane and control plane is done most majorly via Pilot. Now coming towards the next component, which is Citadel. Citadel is like, it actually controls and, it actually is responsible for all the security aspects of your service mesh. So when I say about security aspects, it says about certification management, authentication, authorization. All these things are being handled by Citadel. Now, you might be wondering then what is Istio? Istio just unifies Pilot, Citadel, Galley functionality into a single binary. And this is like recently it has come up. So it is nothing, it just do the functionalities of all the three, but it's combined into a single binary. Uh, and other than all this, I have to talk about, so now with your data plane and your control plane and your service A and service B, your service mesh has been formed. Now, how about the traffic? So when a client wants to talk to your mesh, or it comes via the ingress traffic, okay, all the application, all the calls, all the requests is coming via ingress traffic. And when I say about ingress traffic, obviously it do have its own gateway, virtual service, and destination. So all these destination routes, all these things together for ingress traffic. And so you might be wondering what is this gateway, virtual service, and destination rules. So well, gateway is nothing other than your access point. So when any request comes from your client, that first thing it has to go is via your gateway. From gateway, it will go to your virtual service, which will have all your routing rules routing rules written. So like, Prashant had said, there will be a canary releases where you have to split it between two versions. One is in testing and one is the real one which you are using as of now. So all these routing rules are being written in virtual service. And destination rule is the one which actually helps in load balancing and things like that. And it happens after you hit your virtual service. Now, in order for my any communication to come from external world, I need an external IP or a DNS that needs to be there. So all this, logic is being incorporated in your ingress logic. Uh, Egress traffic is similar but a symmetric logic. When you have when you have to contact an external server or external application which doesn't fall under your Istio mesh, then egress traffic comes into picture. So that's pretty much about the overall architecture, if you see, of and the components of Istio. So now we know that okay, there are certain components, and there are certain IPs that is required, and there are proxy settings that needs to be done. What exactly are the core features of Istio? So to tell, there are plenty of features that Istio provides, but to name few of them, we can say traffic management. When I say about traffic management, it includes load balancing, service discovery, canary development, chaos testing, circuit breaker, retries. So all these things are a part of traffic management. So I'll just go a little bit deep into like what exactly when I say traffic management, how it is. So in order to understand, you first thing for traffic management is like you have plenty of. See, when I say about an application, it's not just consisted of service A and service B. It will have thousands of ports running behind it, right? And you need to really understand what is the network or how the services are going from one service to the other service. So it's like a huge network. It's like a mesh actually. So traffic management actually helps in understanding the interconnection between these services. Then secondly, it is like granular policies, like I said, no, load balancing or canary, where you have two versions and you want to distribute your traffic between these. So these type of granular policies can be written with the help of Istio. While Kubernetes is a great orchestrating tool, but if you see, the best you can give for load balancing in Kubernetes is 50-50. So Istio has like 90-10, any whatever percentage you want, you can put that. On top of that, fault injection, also known as chaos testing. When you are in a production environment, you have a new service, you want to test how does it run, or you have to cover a lot of scenarios. So a fault injection in such a way that you inject some error and you want to see which all it affects, where all it affects, how your overall app is behaving, applications behaving. Also, I would just take some time to explain what is circuit breaking. So essentially, circuit breaking is like you have, one of your services going down, and we can go down because of multiple things. There have been multiple timeouts, or there are too much traffic, there is too much retry that is happening on that service. So when a service goes down, what happens? Eventually, like a cascading failure happens. Whoever is talking to that service will also eventually fails, and your overall application fails. And I don't think in a big production environment, you don't want that to happen. So how do you manage it? You just remove that piece and you make sure that the other things work properly. You don't want to, switch off your entire application. So Istio provides multiple methods in which you can actually do the circuit breaking. And also timeout. And these things are not much there in, Kubernetes or any other tools. So other than service mesh, obviously. So this is what exactly or essentially what traffic management means in Istio. Over to you, Prashant, for observability.
Thank you, Vinita. So the second core feature is observability. There is a quite a bit importance for this, I would say, when it comes to handling different loads of microservices, right? The primary reason why I'm saying it is, as Binita mentioned in the previous traffic management, Kubernetes allows you to have a 50-50% of workload balancing, right? But you're now trying to extend it to 90-10. That's like more power. So as everybody says, with great power comes great responsibilities. Now you have a lot more responsibility when you're trying to handle a lot of more workloads, correct? So in that case, when it comes to observability, three key features are really important. So you need to have a telemetry for every service. Whenever I talk with respect to any service, right, I'm talking about granular level, not from an entire pod or an entire cluster level. It's not a high level thing which we are talking about. It's about very, very fine and granular data, and also logs for all the traffic, not only the ingress and egress, but also the communication which is happening between the microservices between themselves. And also you need to have a service graph, as people say, right? picture is worth 1,000 words. It's the same ideology which these people have been using. So let's look into the other stuff. So one such thing which you can use under Istio is Kiali. This is very specific to Istio, and in a layman terms, what I can say is Istio is just a management console. What I really mean by management console is it actually tells you which microservices are part of your service mesh and how are they connected, how are they performing, and how do you act over them. I mean, how do you operate over it? So these are the various features available from Kiali. I would definitely suggest you to guys start using it. You'll start falling in love with it, believe me. And the second thing is Grafana, where it's more of a graphical thing, which it allows you to see what is a network traffic topology, how is your memory doing, how is your CPU happening, what all the different resource usages happening over your service mesh. These are the things covered as part of Grafana. So when I'm trying to discuss about various tools, right, are they actually mutually exclusive? Not really. So if I have to really talk the differences between Kiali and Grafana, right? Grafana has all the features as supported by Kiali, but I would say it is a subset of the features which Kiali. So it's Kiali is a superset over Grafana, is what I would say. But it has a very good dashboard kind of thing which I wanted to demonstrate to all of you. That's the reason we are talking about Grafana. And the third and most important thing is Agar. So one key feature which I really love about Agar is when you're trying to do a troubleshooting, man, this guy provides a lot of granular data. Seriously, when it comes to tracing, as you see in this picture, right, it tries to show you what are the number of requests happening between surveys. Not only to that top level, as I mentioned, you can track even a single request on what various microservices it has been hopping and where it is taking more time. It allows you to go to that deeper level. It's not like a 10,000 view of a problem. It rather gives you a 10 feet problem saying that, okay, this is the exact place where it has been having a latency for a lot of time. This actually helps you to trace and troubleshoot. And all of this, the diagram which we are showing here, it is actually a static screenshot. But if you really look in the real time, you can click on the dots, you get further options where it actually helps you to trace a single request all over your service mesh, and it is a really a boon for people who are troubleshooting problems. This is more about observability. Now it comes to security.
So, like I said, when we are talking about microservice, obviously microservices are good. It gives you great level of scalability. You can reuse your services, but security becomes a very big concern when it comes to you having multiple services that forms your application. So Istio is actually it's a blessing when it comes to security. There are a lot of features that Istio supports in order to make sure that you have a very secure environment and your all your ports are running in a very secure environment. So to name a few, encryption in transit, there is a service identity that we'll discuss now. Also, authentication and authorization of your user as well as your request. So this is the high level architecture of how an Istio security works. So if you see, right, there are multiple components in this diagram. So the first one I would like to say is about a certificate authority. So certificate authority is the one that is there under these proxies. And this is mainly important for your certificate management as well as your key and certificate management. The second thing that comes is this over here, the API server, configuration API server. And this is responsible for your certificate authority, your authentication policies, your authorization policies, also your network configuration. That comes into the, but like I said, it is a part of Citadel. Citadel does all these things, which comes in control plane. Other than that, you have these proxies, right, which we told about. So these sidecar proxies along with your perimeter proxies, what I'm talking about, the ingress and egress points. So these are called as the policy enforcement points, and to secure communication between the client and server, you need to actually make sure that these are actually secure. Okay, and then you have the set of envoy proxies that extends to manage, that also helps in your telemetry and traffic management or auditing your traffic. Now, so this is like a very high level picture. Now you might be thinking that what exactly is the JWT and TLS, MTLS, right? So when I said that there is authorization that is required, there are two type of authentication that is required. One is peer to peer, and other is request authentication. So when I say peer to peer, it is between the two services that is running within your pod. Any two services that is running with your pod, and that generally needs any sort of encrypted traffic request is fine, which includes HTTP, gRPC, or TCP. So between any two services, you just need a peer authentication. But when I'm talking about the perimeter points, right? So these external traffic and internal uh, internal ingress and egress gateways, right? Then in order to validate a client, you need something called as request authentication. So the first time when he comes, he has to actually get something called as JSON web token that is required for the end user client authentication. Same applies in the egress side also. So that in this way, they make sure that there is no man in the middle attack. Okay, because you have a traffic encryption, and also there is a flexible access control mechanism that Istio provides. Now, having talked about all these things, we know that the main person or the key person behind this is none other than your Citadel. So Citadel is a traffic, your certificate management and your key, everything is being given by your Citadel. That's a part of your control plane. So you see that there is an end-to-end, security when it comes to Istio, whether it is user-related or whether it is service-related, and it actually, helps in runtime identity for every service. Also, you can actually write your own policies inside the proxies, which is mainly which is a person who's responsible for your, who keeps the certificates and keys for establishing connection between two services. Now, when I say about security, there are two types. Like if you have studied the C limits, if you know about it, there are two types even in Istio. One is permissive and one is strict. So, when I say about ports, right, uh, it need not be necessary that all ports are in the same rack, all ports are in the same building. Not possible, right? It can be across the world in different zones. So, how to make sure that you have a secure connection. So in permissive case, right, you don't really need an encrypted traffic or encrypted request. So if you have a microservice service A and a service B, which has a container, but you have not actually put your Envoy proxy in your service A, and if it is an HTTP, all connections will be automatically, made HTTP, and it will be sent to service B proxy, and from there that request will be given whatever it is accessing. Looking at the access policies, it will be granted or denied. So permissive is something which is uh, you know it is good if you are actually migrating to an Istio architecture. Like you still have services that are not migrated to Istio. In that case, you don't want to deny that service, right? So in that case, it is good to have permissive, because eventually you can put your Envoy proxy and make sure that everything is authenticated. But once you have all your services uh, inside your cluster, then you can switch back to strict MTLS. So strict MTLS means that you have a service A, you have a service B, you have a container, but you don't have an Envoy proxy associated with your service A. Then the HTTP, if the request is not validated or if the request is not encrypted, then that request won't be granted. It will be, they'll just give you some uh, a response saying that no, this is not a valid request, or the user is not validated. So strict MTLS is very good when you are running on a high security environment and you want to, actually look after your traffic and look at the request. then strict MTLS is good. Otherwise, permissive does the job, especially when you're migrating to a Istio architecture.
Completely agreed with you, Vinita. As I said before, and I mentioned, right, security will be your biggest enabler any day. So we would like to conclude this session by providing a couple of key takeaways. So I hope by now you guys have a brief knowledge or brief understanding of what exactly is Istio and what are the challenges it is trying to face. So basically, if I have to summarize, right, Istio brings tools to DevOps and site reliability engineering teams to make network concerns on behalf of developers, and so that dev teams can start focusing on delivering business values. So it actually tries to tackles the concerns which microservices have in a uniform and declarative way. As I said before, right, if you are trying to solve some of the issues which you're facing with a microservice, it requires a zero touch on your code base. So that's a key thing which you guys have to understand. So I hope you guys have been enabled to go start using Istio and to get all of its advantages associated with traffic management, security, monitoring, observability. I think we are right on time, and we are open for questions.
Just to add to the point, Istio has a beautiful documentation in the Istio website only, and plenty of documents with support. So you can just go and deep dive, and you'll really get a lot of help from on internet.